Now, we already saw yesterday that we can add and subtract with complex numbers, and also that we can distribute a real number into a complex number. So let's see if we can also distribute an imaginary number into a complex number. So let's distribute negative 3i into the complex number 5 minus 2i. Well, we'll start out the same way we were. So we're going to multiply negative 3i times 5, which we have done before with variables, and we get negative 15i. And then we're going to distribute the negative 3i into the negative 2i, and we'll do that just like we have when we've been working with regular variables like x. So we'll have negative 3 times negative 2 is positive 6, and then I times I is I squared. Now, another thing that we talked about yesterday is that I squared is really equal to a real number. I squared is equal to negative 1. So anytime we see an I squared in a problem working with complex numbers, we're just going to automatically replace it with a negative 1. So this is going to be the same thing as negative 15i plus 6, and instead of times I squared, it's going to be times negative 1. The other thing that we talked about yesterday is that we want to put our complex numbers in standard form. Now, standard form for a complex number is a plus bi. So we will want the real part to come first and the imaginary part to come second. So we'll rearrange this so that it's in the order of negative 6 minus 15i. And that's going to be our answer. Now let's see if we can multiply two complex numbers. As an example, we are going to work with 4 plus I times 6 plus 2i. Now, we've seen problems like this in the past with variables when we were multiplying two binomials, and you may have heard the acronym FOIL, which stands for first times first, outside times outside, inside times inside, and last times last. We're going to use this same process to multiply these two complex numbers. So we will multiply first times first, which is going to give us 24, and then outside times outside, 4 times 2i is plus 8i, and then inside times inside, positive I times 6 is positive 6i, and last times last is I times 2i. So we really have that invisible 1 in front of the I, so 1 times 2 is 1, 1 times 2 is 2, and then I times I is I squared. So that's 2i squared. Now remember that we're automatically replacing this I squared with a negative 1. So really what we have is 24 plus 8i plus 6i minus 2. And then we're going to combine like terms. So we'll combine the real number parts together. 24 minus 2 is 22. And the imaginary parts together, 8i plus 6i is plus 14i. And that is already in standard form, so that's going to be our final answer, 22 plus 14i. Let's look at a couple more examples of multiplying with complex numbers. How about if I had 2 plus 3i and then a squared on that parenthesis? Well, in this situation, I hope you don't want to do 2 squared and 3i squared. I hope that you remember when you have an exponent like that, that really means to take the base that the exponent is attached to, in this case 2 plus 3i, times itself. So 2 plus 3i times 2 plus 3i. And then we're just going to be foiling like we did on the last problem. So we'll take first times first, we get 4, outside times outside, plus 6i. Inside times inside is also plus 6i. And last times last is plus 9i squared. Now we still do want to replace that I squared with -1. We can the more problems we do, the less we have to write down. So if I just replace this with -1, I'm automatically assuming that this is -9. So I can combine 4 and -9 to get -5, and the 6i plus the 6i to get plus 12i. Now let's see what happens if we just change one sign along the way. Let's say instead of 2 plus 3i times 2 plus 3i, we take 2 plus 3i times 2 minus 3i. Let's go ahead and FOIL that the way we did the others. First times first is 4. Outside times outside, bear in mind you have a negative right here, is -6i. Inside times inside is plus 6i, and last times last is going to be a -9i squared because I had a positive 3i times -3i. Now we're still replacing that I squared with a -1, so we really have 4 minus 6i plus 6i plus 9. So 4 plus 9 gives us 13, and then -6i plus 6i cancels each other out. So this ends up just being a real number, 13, with no imaginary part. Now we can do even more complex operations with multiplication of complex numbers. Let's look at this where we have a combination of multiplication and subtraction. Let's take 2 plus 3i minus 5 plus I times 8 minus 7i. Now in this problem we have a multiplication of two complex numbers and we have a subtraction problem. According to the order of operations, we should do multiplication before we do subtraction. So I'm going ahead and foiling first. So I'll keep the 2 plus 3i out in front, and I will keep my foiling in a parenthesis since I have that subtraction there I don't want to lose track of. And I'll do first times first, which is 40, outside times outside, -35i, inside times inside, plus 8i, and last times last will be -7i squared. Simplifying that the way we did the others, we'll still have the 2 plus 3i minus a parenthesis, 40, and now it's plus 7, so 47, and then -35i plus 8i is going to be minus 27i. Now we'll deal with the subtraction problem in here. Remember, we've got to distribute this negative across both of these terms. So I really have a -47 and a positive 27i. When I combine like terms, I have 2 minus 47 is -45, and then 3i plus 27i will be plus 30i. Okay, now for a doozy of a problem. What happens when I have a problem like 3 plus 2i times 5 minus 3i times 2 plus 2i? Well, think back to if you're doing a regular multiplication with three numbers. So let's say we wanted to multiply 3 times 7 times 10. Well, you wouldn't really multiply all those numbers together at the same time. What you're really going to do is take the first two times each other and get 21, and then take that result times 10 to get 210. So we're going to do the exact same process when we have three complex numbers to multiply together. So I will start by foiling these first two. and just dragging the 2 plus 2i along for the ride until we get this part simplified. So foiling that, I get 3 times 5, 15 for the first. Outside times outside is minus 9i. Inside times inside plus 10i. And then last times last will be negative 6i squared. I want to keep that 2 plus 2i at the end so I don't forget about it when I'm finished. And remember, we're replacing that I squared with negative 1, so that's really plus 6. And combining like terms, 15 plus 6 is 21. Negative 9i plus 10i is plus I. And then times my other parenthesis, 2 plus 2i. At this point, I'm just going to FOIL again. So I'll take first times first, which is 42, outside times outside, plus 42i, inside times inside, plus 2i, and last times last, plus 2i squared. There's that I squared again, which makes this a negative 2. So at the end, when we combine like terms, I have 42 minus 2 gives me 40, and 42i plus 2i is plus 44i. And that is the end of the road.